Okay, so today we're going to learn how do we round our answers to the correct number of sig figs. And there's two main types of rules. So one is if you're adding or subtracting, and then the second rule is if you're multiplying or dividing. Okay. So today we're going to start with addition and subtraction. So if you're adding or subtracting, your answer has to have the same number of decimal places as the measurement with the least number of decimal places. Okay. So I'm going to give you like a minute to copy just like our rule down, and then we'll go through the examples and I'll show you like how does the rule apply to our examples. And if you need like the one word reminder of how to remember this one, I think of like the D's and add, and I think decimal. Okay, so when we're adding or subtracting, we're counting decimal places. Okay, so when we calculate these problems, go ahead and get your calculator out, and we'll do this top one first. Go ahead and just enter it in your calculator exactly how you see it. So take 4.3 plus 5.20 plus 11.78. And then once you get an answer, someone tell it to me out loud. Okay, 21.28. Do you all agree? Okay, so now we're going to round at the end. So your answer has to have the same number of decimal places as your least precise measurement. So how many decimal places are in 4.3? Okay, just one. How about 5.20? 2 and 11.78? 2. So this one has the least and it only has one. So therefore your answer can only have one decimal place. So I just draw a line under that one decimal place, and then you have to look at that next digit. So the next digit is an 8. Is that going to cause us to round up or down? Up. So what are we going to round it to? Okay, so our final answer is 21.3. And then let me just kind of explain that conceptually. So you have to think in the world of chemistry, you have to get your numbers from measuring. Right, we would be in the lab measuring something. If one of your instruments can only measure to the tenths place, could you really give an answer in the hundreds place? Are you sure about that number? Right, we're not sure. So you can't give an answer in the hundreds if you're limited to the tenths. So whatever your most limited measurement is what your answer has to be in. Does that make sense of why we have these rounding rules? Okay, let's do the second one. So go ahead and type in 15.99 minus 5.5. And then if you have the answer, will someone just tell me out loud? 10.49. Okay, so you should get 10.49. And then we'll round at the end. How many decimal places in 15.99? Okay, 2. How about 5.5? 1. So how many decimal places can your answer have? Okay, just 1. So I'm going to draw the line under the 4. And then we look at that next digit. Is that going to cause us to round up or down? Up. So what do we round this to? 10.5. All right, our second rule is for multiplication and division. So for multiplication and division, your answer has to have the same number of sig figs as the least precise measurement in the calculation. Okay. So if you need the one or two words just to trigger this one, multiplication and division, we're interested in sig figs. So again, I'll give you a minute to copy the definition, and then we'll do those practice problems together. Okay, so go ahead and just type this into your calculator. So what's 5.25 times 6.0? Okay, 31.5. Do y'all agree? Okay, so then this time we count sig figs. How many sig figs are in 5.25? 3. How about 6.0? 2. So whatever the lowest number is, that's how many sig figs can be in your final answer. So how many sig figs in that final answer? 2. Okay, only 2. So I just put a line over the second sig fig, and then again you have to look at that next number. It's the 0.5. Is that going to cause us to round up or down? Up. So what are we going to round this to? 32. Okay, so we'd round that answer all the way up to 32. Okay, next type in 25.0 divided by 5.0. And your calculator gives you 5. Okay. How many sig figs are in 25.0? 3. How about 5.0? 2. So how many sig figs does your answer have to have? 2. So what do we have to do to turn 5 into 2 sig figs? Okay, you can add the 0.0, so it becomes 5.0. All right, so real quick, I just want to review rounding numbers. So if you know this, you don't necessarily have to write it down, but if you're a little rusty on rounding, go ahead and write these down. If your decimal or even your next digit, if it's under 5, it's going to cause you to round down. And then if your next number is 5 or higher, it's going to cause you to round up. Okay, so for example, let's say it's 25.5. That 5 is going to have you round all the way up to 26. Let's say you have something like 13.3. That 3 is going to have you round all the way down to 13. All right, so we're going to practice. On this side, I have 2 like addition, 2 subtraction, 2 multiplication, 2 division. Okay, so get those calculators out, and we'll pretty much just go through these together. So the first one up there, go ahead and take 0.00598 plus 0.004 in your calculator. And then someone just tell me the answer. We'll round it together. All right, what are you getting in your calculator?
0.00998.
Good. Do you all agree? Okay, so first step, I would just say put it in your calculator. And then second, we'll worry about rounding. So then you're adding. Are you worrying about decimal places or sig figs? Okay, decimal places. How many decimal places does this number have? 5. How about this one? 3. So how many has to go in your answer? Okay. So that's our third decimal place. I'm going to look next to it. That 9, what's that 9 going to cause us to do? Okay, it's going to round this up. So think of it rounding up to 10. So it's going to become like 10. So we're going to round it to 0.010. And if you're given a unit, add your unit in there. Okay, do we feel okay with that first one? Okay, 79.6 plus 0.0168. Okay, 79.6168. Okay, we're adding, so are we counting decimals or sig figs? Okay, how many decimals in this one? 1. How many in this one? More than 1, correct? Okay, so how many can your answer have? Just 1. Okay, so I draw the line, I look over. What does that 1 cause us to do? Okay, so it's 79.6 milliliters. Okay, next we have 27 liters minus 0.0838 liters. What do you get if you type that into your calculator? $26 something, yes.
26.9162.
Okay, hold on. 26.9162. Thank you. All right, we are subtracting. Are we counting sig figs or decimal places? Okay, decimal places. 27, does it have any decimals? Okay, do I even need to look at this number, or what do I automatically know? Okay, I know my answer can't have any decimals, so I don't even have to spend any more time looking over here. So that means my answer has to end in the ones place. So look at the 9. What does that cause me to do? Okay, so you end up with 27 liters. Is it okay that my answer is still what I started with? Yeah, I mean, think about it. If I had 27 liters and I just took out like 0.838 liters, is it still essentially 27 liters? Okay. 420 centimeters minus 19.11 centimeters.
$400.89.
400.89. Do y'all agree with that? Okay. Are we counting sig figs or decimal places?
Decimal.
Okay, decimal. How many are in 420? Okay, none. So how many can your answer have? None. So you have to end in the ones place. I look over though, and that 8 is going to cause us to do what? Okay, so what should my answer be? Okay, 401. Okay, next we have 6.77 kilograms times 0.9 kilograms. Thank you, 6.093. Okay, are you counting sig figs or decimal places? Okay, this time we're going to count sig figs. How many sig figs are in 6.77? 3, and how about 0.9? Okay, 1. So how many can your answer have? Okay, just 1. So that's our first sig fig, but you always got to check that second number. So how are we going to round it? Okay, so just 6. For units, what's a kilogram times a kilogram? Kilogram squared. Okay. Next, 16.2 times 23.79. Okay. 0.398. Okay. And are we counting sig figs or decimals? Okay, sig figs. How many sig figs in 16.2? Okay, 3. How about 23.79? 4. So how many does your answer have to have? 3, because of this number. So that's our third sig fig, and we look over to the 3. So how are we going to round it? Okay, so we keep it at 385 milliliters squared. All right, and then finally we're going to divide. What is 596,000 divided by 0.0023? Someone can just read me the numbers because it's a large number. Who's got the number? Someone type it in and then just read the numbers.
2591.
Okay, 259130.
434.
Hold on. 2591.
304. 34.
0.8. Phew. Okay, are we counting sig figs or decimals? Okay, sig figs. How many in 596,000? Okay, 3. How about 0.0023? 2. So how many can your answer have? 2. Okay, so that's our second sig fig. What's that 9 going to cause me to do? Okay, round it up. There's 2 different ways you can write your answer. You can do standard notation. So I'm going to round that up to a 6. And then all of these digits are just going to become zeros. So then I'm going to write 0, 0, 0, 0, 0, 0, 0. Okay. How many of you enjoy writing that many zeros? 7 zeros. Is that kind of obnoxious? Okay, so we should convert this one to scientific notation. Okay, so the best answer would be 2.6 times 10 to the 8th. I'll circle that so we can kind of see it. Okay, so you could do standard, but like 7 zeros is obnoxious. So convert that one to scientific notation. And then last one, 56.200 divided by 260.5 grams. What do you get?
0.2573896.
Okay, that's probably enough. I hope that's enough. Okay, are we counting sig figs or decimals? Okay, how many sig figs in 56.200? Okay, 5. How about 260.5? Okay, 4. So how many does your answer need? Okay, 4. So that fourth sig fig is at the 7, and we look at the 3, so we're just going to leave it then. So 0.2157. Okay. Do we feel okay with those? Okay. We're going to do more, but for the moment, are we okay? Okay. Along with like adding, subtracting, multiplying, and dividing, we're going to convert temperatures in this class a lot. What unit do you probably prefer your temperature scale in?
Depends. Are you
Like in your everyday life. Like your personal preference is probably in Fahrenheit. When we use the thermometers in this room, what unit are the thermometers going to give you? Celsius. And then sometimes we'll use kelvins, especially in like our gas law unit, we'll have to convert to kelvins. So you do need to get comfortable on how you convert temperatures. So on the left side, I give you the equations. Go ahead and just copy these in your notes so you have them. You do not need to memorize these. Like if you have to convert a temperature on like a test, I will give you this equation, okay? So you don't have to memorize it. However, it's nice to have these all in like one spot in your notes. So get them in your notes. Kelvins is just capital K. So to get to kelvins from Celsius, you just add 273. And then to get to Celsius from Kelvin, it's just your temperature in Kelvin minus 273. And then to calculate Celsius from Fahrenheit, it's Fahrenheit minus 32, and then times 5/9. And then I have Fahrenheit from Celsius is 9/5 times Celsius plus 32. And I kept parentheses in here. If you get the parentheses in here and you like use these parentheses in your calculator, then your calculator should do correct order of operations. Okay, so like use the parentheses where you see them. Okay, we're going to do 2 temperature conversions. The first one, we're going to convert 68 degrees Fahrenheit into Celsius. Okay, so we have to find our equation. So we're solving for Celsius from Fahrenheit. Okay, so we're going to use the third equation up there. So we're going to take our 68 degrees and subtract 32. And then you're going to multiply that by 5/9. Okay. So if you keep the parentheses and put it in your calculator with the parentheses, your calculator should do correct order of operations then. Okay, so everyone practice, type this in, make sure you're getting the correct answer out of your calculator. Okay. When you type this in, what kind of number are you getting? Like 20?
I got 20.
Okay, just 20? Okay. Sig figs for temperatures can be a little confusing because we're either adding or subtracting and then we're multiplying. Typically, I'd say the good rule of thumb is however many sig figs you start with is how many should be in your answer. Okay, so how many sig figs are in 68? 2, so how many should be in your answer? 2. If I just add a little decimal point, does that turn it into 2 sig figs? Okay. And then don't forget your units. So we have 20 degrees Celsius. Next, let's convert 90 degrees Fahrenheit to Kelvin. If you look at our equations over here, can you go straight from Fahrenheit to Kelvin? Okay, there's no equation that gets you just from Fahrenheit to Kelvin. So what unit do you have to convert to in between? Okay, so we've got to go to Celsius in between. So we'll take 90 minus 32 times 5/9. And for like the sake of my practice problem, if you get an answer, will someone just like yell what you get out loud?
Sure.
Thanks. All right, who's getting a number? It's something 0.2222, correct? I remember this. What is it? Is it 32.22222? Okay. Now on your calculator, it is best for you not to round until the very end. Okay, so don't round here. So yours is like 32.22, like repeating twos, yes? Okay, so like best math practice is you save rounding until the very end. So then you're going to take your Celsius number and you're going to add 273 to it. Since I'm just writing it on like my screen, I'm going to like rewrite it like this to show you. How many of you have the option in your calculator to like keep this answer with the never ending 0.222s and then you can just add 273 to that answer? Okay, that is like best practice. So if you can just copy this answer and add 273, that's like the very best option. So don't round it yet. Okay, and what's 32.222 plus 273? Okay, 305.22 repeating, correct? Okay, so then we'll round it at the very end. If we started with 2 Sig Figs, how many Sig Figs should we have in our answer? Okay, 2. So how can we round 305 up to 2? We're going to round it all the way up to 310. Okay, the last thing we need to talk about is just how do we evaluate measurements. Nothing to write for this slide. Okay. However, when we're in the lab and we're making measurements, is there always going to be some like little bit of error? Always. Even the world's best lab measurer out there is always going to have some sort of error when they make measurements. So we have to have some sort of way to measure that. Okay, so how close is your measurement compared to the actual value? So before we can get into how we calculate percent error, you do just need to know these two little definitions. Okay, the accepted value is like the true or correct value. And that's based on reliable references. So if you had a whole bunch of chemists measure the density of copper and they were all getting 8.95 grams per centimeter cubed, could we agree that like if 20 professional scientists got the same number, we could call that like the correct value? Okay, so for you, this is the value we'd either look up or I'd give you this value. Okay, and then the experimental value is the one that you measure. Like when you do an experiment, this is the one that you would get. So I think a couple weeks ago, like you measured the density of copper. This would be like what you measured the density of copper to be. So this one's given to you. This one you generate typically on your own. Okay, so then we're going to take those definitions and we're going to plug it into our equation for percent error. So to calculate our percent error, we take our accepted value minus our experimental value, divided by the accepted value again, and then you multiply it by 100 to turn it into a percent. Okay. So go ahead and copy this equation and then we'll do one practice problem of calculating percent error. So let's practice calculating percent error. Let's say you measured the density of silver to be 10.3 grams per centimeters cubed. You look up the true value to be 10.5 grams per centimeter cubed. What's the percent error? So percent error is the accepted value minus experimental. Which one of those numbers do you think is the accepted value? Okay, so 10.5 is the accepted value. And then what's the experimental? 10.3. And then you divide it all by the accepted again. which is, okay, 10.5. And then multiply it by 100. I want to kind of break this down just to show you how to track sig figs. So we're going to start with inside the parentheses. What's 10.5 minus 10.3? Okay, 0.2. Okay. And then we're going to divide it by 10.5. Okay. If we're dividing now, are we counting sig figs or decimals? Sig figs. How many sig figs are in 0.2? 1. So we're going to round your answer just to 1 sig fig. So if you do 0.2 divided by 10.5 times 100, what like full number do you get in the calculator before you round it? 1.9. Okay. And we're going to round it up to that 1 sig fig. So we're going to round it up to 2%. Okay, are we okay on how to calculate that? Okay, one little rule of thumb, 5% error or under is what you're looking for. That means like you have good lab techniques. So if we're doing a lab and at the end you calculate your percent error, you want to be within 5% error. Okay, so if you're within 5%, it means like you made good measurements. Okay, if you're over 5%, it means like you had like a huge mistake. Okay, so something went wrong. Maybe you measured something wrong. Okay, so like 5% is your target number. Could you theoretically get like a minus 5% if you use this equation? Yeah, if you ended up measuring more than the true value, you end up with like a negative percent. That just tells you you have more than you should.